Lesson 11, Comparing and Contrasting Data Distributions. Learning target, I can arrange data sets in order of variability given graphic representations. Let's review some important concepts you've learned before. The mean absolute deviation, or MAD, is calculated by finding the mean distance from the mean to all the data points. Interquartile range, or IQR, is found by subtracting the first quartile, Q1, from the third quartile, Q3. How should you compare measures of spreads for two distributions? Say, for example, you have two distributions best represented by the mean, such as the two roughly symmetrical distributions. You calculate and compare the MAD. Whichever one has the lower MAD has less variability. So in the two examples, you can see that this one is less spread out, so it would have a smaller MAD and less variability. What if you have two distributions best represented by the median, such as the two skewed distributions shown here? Which distribution would have less variability? You calculate and compare the IQR. Whichever one has a lower IQR is less variable. Again, we can take a look and see how they're spread out. This one is more spread out, this one is less spread out. This one would have a smaller IQR. In summary, we compare MAD values for distributions best represented by the mean. We compare IQR values for distributions best represented by the median. And the lower the IQR, or lower MAD, means the distribution is less variable or has less spread. Here are two dot plots, each with a mean of 15 centimeters, displaying the length of sea scallop shells in centimeters. The data in the first dot plot appears to be more spread out than the data in the second dot plot. So you can say that the first data set appears to have greater variability than the second. We should compare the variability of the two distributions using MAD. Notice that both dot plots show a symmetric distribution, so the mean and the MAD are appropriate choices for describing center and variability. The MAD of the first data set is 1 in 1800 centimeters, and the MAD of the second data set is 0 in 9400 centimeters. This means that the values in the first data set are, on average, about 1 in 1800 centimeters away from the mean, and the values in the second data set are, on average, about 0 in 9400 centimeters away from the median. This shows us that dot plot A has greater variability because it has a greater MAD. Notice that neither of the box plots have a symmetrical distribution. The median and the IQR are the appropriate choices for describing the center and variability of these data sets. The middle half of the data displayed in the first box plot appears to be more spread out compared to the data in that one, or show greater variability than the middle half of the data displayed in the second box plot. The IQR of the first distribution is 14 centimeters and 10 centimeters for the second data set. The IQR measures the difference between the median of the second half of the data, Q3, and the median of the first half, Q1, of the data. So it's not impacted by the minimum or the maximum values of the data set. It's a measure of the spread of the middle 50% of the data. So box plot B has less variability because it has a lower IQR.